Hi, welcome to Chemistry Made Easy. Today we are going to look at redox reactions and half equations. When we talk about a redox redox reactions are basically reactions in which there is a change in the oxidation number of relevant species. Or you can basically say redox reaction is a reaction between an oxidizing agent and a reducing agent. Now, when we talk about redox reactions, these are reactions that involves oxidation and reduction. Now, when we talk about oxidation and reduction, what are they in relation to redox? Let's look at the definition for oxidation and reduction regarding redox. So, oxidation, reduction. When we talk about oxidation and the redox, we said oxidation is the addition of oxygen to a substance. So when we add oxygen to substances, we said that particular substance has undergone oxidation, whilst reduction deals with the removal of oxygen. Oxidation can also be defined as the removal of hydrogen. The removal of hydrogen from a substance, whilst whilst reduction is the addition of hydrogen to a substance. Oxidation is also the loss of electrons. Okay, so when loss of electrons. So when substances lose electrons, we say they are undergoing oxidation, whilst reduction is the gain of electrons. Oxidation also can be defined as the increase in oxidation number. Whilst the increase in oxidation number of relevant species, whilst reduction is the decrease in oxidation number of relevant species. So these are the definition for both reduction and oxidation. Now that we have seen the definition for reduction and oxidation, let's look at what redox half reactions are. So let's look at a half reaction. When we talk about a half reaction under redox, it's basically a reaction or equation that have an oxidation part and a reduction part. Okay. Redox half reactions or equations. A redox half reaction or an equation is an equation that have both an oxidation part and a reduction part. Let's take an equation and identify what redox half reactions are. Let's say I have this equation. Zinc react with copper sulfate to give us plus a zinc sulfate. Now, let's rewrite this equation in its ionic form. So in its ionic form, I'm going to have zinc in the solid state giving me copper once it is in an aqueous solution to dissociate into ions. So I'm going to have a Cu2 plus aqueous. Then I have an SO4 2 minus aqueous. This will give me my Cu solid plus zinc also is in an aqueous solution, so it will dissociate to give me ions. So zinc 2 plus aqueous plus SO4 2 minus aqueous. This sulfate is known as spectator ions. Basically, spectator ions can easily be identified in the equation when you see them on both ends of your equation, so they can cancel out. So this goes off, and I have Zn plus my Cu aqueous 2 plus to give me Cu solid plus Zn2 plus aqueous. The next step is to identify their oxidation state using the rules in oxidation. So this carries an oxidation state of 0. This is plus 2, 0, plus 2. Now, in the definition for oxidation, we said that oxidation is the increase in oxidation number of our relevant species. So you can see that zinc was 0. Zinc here is plus 2. What happened to zinc? It increased in oxidation number. So this side is undergoing an oxidation half reaction. Then reduction, according to our definition under redox, we said it is the decrease in oxidation number of relevant species. So you will see that copper here was plus 2, it decreased to 0. So this copper is undergoing what we call a reduction half reaction. So that is how we identify oxidation half equations and reduction half equations in a given redox reaction. So note that either an oxidation half or a reduction half, it cannot be considered as a redox equation or reaction. A redox equation or reaction must be made up of the two parts. That is the oxidation half reaction and the reduction half reaction. I hope you understood this lesson. If you did, I urge you to subscribe and then hit that notification button.